Hey guys, welcome back to Breakup. Today we're doing another Brainstellar Quant puzzle. This one is called Expected Breakup Length, a hard problem. So I'll let you guys go with the problem once. So what the question states is that we've been given this stick of unit length and it's broken into three pieces by randomly choosing 2 points. So let's just choose two random points P1 and P2. And choosing these 2 points and breaking the stick above these 2 points will lead us to three separate parts. And let's just call the length of each of these parts X, Y, and Z as in this order that is depicted. And so what we've been asked is the value E of Y, or the expected length of the middle part. Right. So we'll be going over three ways to solve this problem. And let me start with the first solution. So the first solution is based on the fact that I try to look at the problem in a different perspective. So instead of looking at the problem in terms of choosing 2 points, what I did was, so we already know that eventually there's going to be three different parts, right? So if I just call those three parts X, Y, and Z, or as we defined earlier, and this is always true that X plus Y plus Z is always going to be equal to 1, right? So now try to imagine the problem from a different perspective. Imagine that we have this one container of continuous volume, right? So this container has a volume of 1, and we have to split this into three separate smaller containers, and the amount of volume that goes into the first container is X, the amount that goes into the second container is Y, and similarly for the third, right? So this is a scenario where we're splitting 1 unit of volume into three containers X, Y, and Z. And the reason why I chose volumes because I just want you to provide a feeling for continuous values, right? Since the amount of liquid in a container or the volume is a continuous value. So over here, since we're randomly splitting this 1 unit into X, Y, and Z, it's safe to say that the expected value of X is equal to the expected value of Y and is equal to the expected value of Z, since X, Y, and Z are completely symmetrical, right? Now, if you come back to this equation that we had earlier, well, imagine the problem as we have this 1 unit length and we're trying to split it into three separate lengths. And the way we split it is, well, you could say that we randomly choose three subparts and give it to X, Y, and Z, or we randomly choose 2 points. And about those 2 points, we will automatically get three subparts and then we split them among the three. So what I'm trying to say is the scenario of randomly choosing 2 points is completely identical to randomly choosing three subparts or substicks, if you will, right? So I'm just converting the problem of where we randomly choose 2 points on that 1 unit length stick to randomly choosing three substicks of lengths X, Y, and Z, each having the constraint of X plus Y plus Z has to be equal to 1, right? So now let's come back to the equation we had, which was X plus Y plus Z was equal to 1. And because of the symmetry we just defined earlier, E of X is going to be equal to E of Y, and that is going to be equal to E of Z, right? So talking about this equation, let's just define E of X plus Y plus Z. But that's always going to be 1 because this value in itself is always going to be 1. And splitting the expectation about the addition signs, which is allowed, we have E of X plus E of Y plus E of Z is equal to 1. And we know that this and this is the same as this. So we get 3 times E of Y is 1. And that gives us the answer to the problem, which is the value of E of Y that we had to calculate as 1 by 3, which is the solution to this problem. Now, if you're still not satisfied with the reasoning I gave earlier, let's think of it from a different perspective. So imagine we have a unit length circle. Now, when I say unit length, I mean the perimeter, right? The perimeter of this circle is of unit length. So basically, I've taken this stick and I've made a circle out of it, wrapped it around itself. So now, if we choose three random points on this circle and name them breakpoint, point 1, and point 2, then, well, a random arrangement could look something like this, where this is breakpoint, this is point 1, and let's call this point 2, right? Now, well, since I just took three random points on the circumference of this unit length circle, it's pretty safe to say that this value, and this value. So when we choose 3 points, we're basically effectively breaking it into three different arcs. Now, the length of each of these three arcs is gonna be symmetrical on average. So if we call this X, we call this Y, and if we call this arc length Z, then E of X is going to be equal to E of Y is equal to E of Z, right? Now, over here, it's like pretty obvious because all we did was we chose three random points on the circumference, right? So the three sub arcs that we're going to end up with are going to be symmetrical. So the expected length of the three sub arcs is going to be equal. Now, all you have to do is realize that when I termed one of these points as breakpoint, all we're doing is breaking the circle at this point. So what we're effectively going to have is from big point all the way up to point 1, then we're going to have point 1 all the way up to point 2, and point 2 all the way up to breakpoint again. So the reason why I defined one of them as breakpoint is this is going to be the point that we're going to break the arc length, or break the circle rather, about which, and we're going to make it back into a straight line. So this length is still going to be X, this is still going to be Y, and this is still going to be Z. And using the symmetry case that we just proved above, we are going to end up having again the same value of E of Y going to be equal to 1 by 3. Since X plus Y plus Z is in this case also equal to 1. Now there's a third solution which is a bit more brute forcey. So let's go over that solution now. Well, looking at the very original problem, okay, so we have a stick and it's of unit length and we choose 2 points. So let's call them X and Y. So, well, if we just choose 2 points X and Y, then the length of the middle part is going to be mod of X minus Y. Now, why do I say mod of X minus Y and not just simply Y minus X or X minus Y? Well, we don't know if the point Y is going to be ahead of X or behind X, because so far I've just defined 2 points randomly chosen from 0 to 1, right? So we have 2 points or 2 variables randomly chosen from 0 to 1, and what we need is the expected value of E of mod of X minus Y. So using simple mathematical formulas, the expected value of E of mod of X minus Y, well, this is going to be, now because these are continuous variables, it's going to be something like this. This is the standard formula to calculate the expected value of a function. Now, the only thing that's not defined is f of x comma y, which is basically the probability density function. And this can be simplified pretty easily because we know that x and y are independent variables, because the question states that they are independent points chosen randomly. So we can say that f of x comma y is basically f of x multiplied by f of y. And since f of x and f of y are chosen randomly, that means they both come from uniform distributions. And it's a pretty common result that the PDF, or the probability density function of a random variable, is 1 upon b minus a, where the random variable x in itself ranges from a to b. And it's 0 for every other case. So if x is any value outside of a to b, it's 0. Now for our case, b is equal to 1 and a is equal to 0. So f of x, and it's going to be the exact same for f of y, since it comes from the exact same distribution, is going to be 1 over 1. So it's just 1. So we can omit this term altogether. So our simplified formula comes out to be, so ultimately our equation is going to look something like this. And now all you have to do is solve this integral, double integral over here. Now, using the property of symmetry, we're going to break this integral into 2 halves. So if we look at the mapping on the graph, this is the area over which we have to integrate, which is the unit square, right? Because x and y both loop from 0 to 1. So originally we were to integrate over this entire area, but we're going to use the property that this integral is going to be symmetric around the x is equal to y line. And benefit of using this x equal to y line, so if we only try to integrate over 1/2 or one triangle of the two, then we can simplify this x minus y modulus value. So let's just use this area over here, and for this area we can see that x is always greater than y. So we can just use, instead of modulus of x minus y, we can just use x minus y. So using this simplification, and by the way, so once we calculate the integral for this area over here, this triangle, we're just gonna multiply the entire answer by 2 to get the answer for this entire square. So now our equation is gonna look something like this. But we still have to figure out the integrals. So coming back to the area we just defined, we're trying to integrate over this area, where this is the y is equal to x line. This point is 1, comma 1. This point is 1, comma 0. And this is the origin. So we've changed the ordering of the y and x variables, and that is because of the element that I'm just about to choose. So if you have done double variable integrals before, we have to basically come up with an element. So the element I've chosen is this part over here. So basically what's happening is, first of all, y is ranging from 0 to x, from this point all the way up to this point, and then x in itself is ranging from 0 all the way up to 1, and then so this is the range for y, and then x maps from 0 all the way to 1. So the integral limits basically become, for the y variable, it's from 0 to x, because this is the y is equal to x line, and then for the x variable, so basically this stick is going to go for x equals to 0, which is going to be the smallest stick, and then all the way up to the largest stick, which is going to be for x is equal to 1. So basically these are the stick elements that we're choosing. So x goes from 0 to 1. So now this is the final integral that is pretty easy to solve. This can be solved just using very simple integration formulas. So I'll just solve this and fast forward to come to the answer. So yeah, so this is the integration over here, and as you can see, we come up with the answer of 1 by 3, which is the exact same solution. I hope you guys understood all of these three solutions, and thanks for watching.